So in this question number 7, we have a crate resting on a ramp, and the ramp is angled at 30 degrees. Resting means it's not moving. So F net, which is the sum of the forces, has to equal 0. So we know everything's balanced. So let's look at what's on here. Well, we know that gravity is acting down. We know there's a normal force, and the normal force is going to be perpendicular to the surface. So it's going to not be in line with gravity, but off at an angle. Now, is there any other forces acting? Well, if you look at just these two forces, you can see that they kind of add up to a force that's sort of down the slope. So in order for this crate to be resting, friction has to be holding it in place. So we're going to draw a force of friction holding it there. And those are the three forces that we have. This is one of the examples where we're going to rotate our axes. So we're going to make our y-axis like this, and our x-axis is going to be like this. And that way, we can have the normal force and the frictional force in one direction, and that's in the y direction, and in the x direction, and sorry, the normal force is in the y, frictional force in the negative x, and then we're going to resolve our force of gravity into its parallel and perpendicular components. So this is the along the slope, FG, X, and then the down the slope. So this one would be FGY. So then solving this question, y. All right, so then looking at this question, this angle's 30, which having done this a few times now should tell you that this angle is 60. So to find FGX, we're going to say FG, and it's going to be cosine of 60 degrees. Now, what is FG? Well, we can solve that right now, because FG is just equal to mg. The mass in this example is 10, so 10 times 9.8, which equals 98 newtons. So we have 98 newtons. So using that in here, we have 98 cosine of 60, that works out to 49 newtons, I believe. Okay, so then finding the y component, FGY, it equals FG sine 60, which equals 98 sine 60. So this works out to about 84.9 newtons. And so we found our x and our y components. Now, to do what the question is asking, we have to find the net force. We need to know what the force of friction, and we need to know what the normal force is. So we're going to analyze this in the parallel and the perpendicular. So in this case, parallel means in the x direction, parallel to the slope. And when I look parallel to the slope, I know that F net equals 0. Right? Because it's resting. So 0 equals, well, what are the forces acting along the slope? We've got FGX acting in the positive x direction minus the force of friction. So I know that friction has to equal FGX, which I've already figured out. Force of friction has to equal 49 newtons. So that's the answer that's the value of FF. So that's one of them, FG, that's another one. And then the last one we need to figure out is the normal force, and in order to do that, we'll look at the perpendicular direction. So perpendicularly, again, F net equals 0. So 0 equals the sum of the forces. In this case, all we have is Fn minus Fg in the y direction. So that means Fn has to equal Fgy, and we know what that is, so Fn equals 84.9 newtons, and that's the answer. So we have all of our values. Again, it's interesting to note that the normal force is smaller than the force of gravity, and that's because only a component of the gravity is pushing down on the slope. The other component of it is trying to pull the object down the slope. So its value would be a little bit smaller than the force of gravity if it was just on a flat surface. The other thing interesting to note is the bigger this angle theta gets, like 30, 40, 50, 60 degrees, the bigger the component of FGX is, the greater the component trying to pull the box down the slope is. And so and so therefore you need more and more friction to overcome that. Eventually what ends up happening is the force of gravity in the x direction overcomes that force of friction, and the box will eventually slide down the ramp, but we'll get to that in the next lesson.